We're going to talk a bit about abstraction. We're going to use Leetcode 134, gas station. Now I'm going to read the problem. There are n gas stations along a circular route where the amount of gas at the ith station is gas at index I. You have a car with an unlimited gas tank and it costs cost at index I of gas to travel from the ith station to its next I plus 1th station. You begin the journey with an empty tank at one of the gas stations. Given two integer arrays, gas and cost, return the starting gas station's index if you can travel around the circuit once in the clockwise direction. Otherwise, return -1. If there exists a solution, it is guaranteed to be unique. Now we can think of this as described, but for me, that makes it a bit more complicated. So let's try to break down, just in terms of values, what this is actually saying. So I am going to write out the first example. We'll just call it array 1. The values are 1, 2, 3, 4, 5. Okay, now the next one we'll just call array 2. They call it cost. And the values are 3, 4, 5, 1, 2. Now, what are they actually asking us to do with these values? Well, let's try to get a better sense of that. It costs cost of I of gas to travel from one gas station to the next one. So, at each index, we subtract A2 at I from our total. Okay, so let's have a total variable. Okay, we start at 0. So each time we arrive at an index, we add from A1 and we subtract from A2 when we go to the next index. So let's take a look. If we're starting at index 1, so let's write I equals 1. The total gets incremented to 1. But then it gets decremented by 3 and it becomes -2. So we can't start at index 1. So let's start over. Start at I. I said I equals 1, but that was actually I equals 0. So let's correctly start at I equals 1 this time. So we have 2, or our total is 0. So we add 2, then we subtract 4, we get -2. We can't start there. Let's move on to index 2. So index 2, let's cross this out. We're back at 0. So we add 3. We subtract 5. We get -2. So this doesn't work. Let's start at index 3. 0, 1, 2, 3. So our total becomes 4. And we subtract 1 and we're at 3. Okay. So this is our first candidate. All right, this is the first time, this is the first index where we can increment by the value of A1 at index I, decrement by A2 at index I, and remain above 0, or as they say, have gas in the tank. So 3 is our first candidate. So we'll just put candidates 3. That's the first starting point we have the option of using. Okay. So let's go to index 4. So we're done with that. And we know we're going to increment this. So let's just stay in blue. So we're now at index 4, 0, 1, 2, 3, 4. So we subtract 5. Okay. So 5 goes to negative 2. And then we add 2, which brings us to 0. Okay. Let's see. Does that make it a valid? No. I must have done the math wrong there. 3 A1 is guessed. I did that backwards. Sorry. So we were at 3. We add 5, get to 8, subtract 2, get to 6. Okay, so we still have gas in the tank. So remember, this is supposed to be a circle. So once we get to the end, we just go all the way back to the beginning. So now we're at index, oh, sorry, the candidate is still 3. We're at index 0. We have 6 plus 1 gives us 7. Minus 3 gives us 4. We're still good. Let's go to index 1. So we add 2. Let's go down to the next line. So we have 6. Then we subtract 3. We're at 3. We're still above 0. Now we'll go to index 2. 0, 1, 2. So we add 3 to get 6. Subtract 5. We have 1. And now we're back at index 3, which was our candidate. So if we can add index 3, subtract index 3 from A2, we're good to go. But we've already done that, right? So we can go ahead and return 3, because we can start at 3 and get all the way back to 3. And the constraints say that if there is a solution, it's going to be unique. So once we find a solution, we can go ahead and return it. We don't have to keep looking for a better solution. And now, if you don't mind, a little help cleaning off my desk so we can view an animation. Okay, so we're going to do a little bit of cleanup here, and then we're going to do a walkthrough of our algorithm to show how we can solve this problem in big O of n time, just iterating through the length of our arrays one time. So we have our two arrays, gas and cost. Let's line these up a little better. There we go. We'll keep track of our index, dang it, starting at 0. And at each position, we will keep track of the contents of our tank by adding whatever is in the gas array at that particular index and subtracting whatever is in the cost array at that index. If our tank goes into the negatives, then we cannot start at that particular index. So we'll cruise on over to the next one and start the algorithm again. When we find a position where our tank remains non-negative, then that is our start candidate. Now we've reached the end of our array, and our answer is I equals 3. But I want to continue the algorithm just to show you that it is in fact the correct answer. There are some arithmetic mistakes here. I tried to go back and correct them, but got tired of doing that. So point being, we stayed above 0, so the answer is still the same. Okay, let's go ahead and write some code for this problem. So in our illustration, we had our tank, but I'm just going to go ahead and call it total for now, because that's the variable I've used in the past, and it'll make it easier for me to write this. And so our start candidate, we're just going to call start. And that is going to just start at none, actually. Now, let's think of something really quickly. Let's say we have In our gas array, all ones. And then in our cost array, we have all ones but 1, 2. If we do the sum of cost and it's greater than gas, there's no way that we can afford to visit each station. So I'm just going to put a little line of code up the front here. So if the sum of gas is less than the sum of cost, then there's no need to run this thing. And we'll just go ahead and return -1. So we've got our two variables. We've got start, we've got total. So now we're going to iterate through. So for I in range, the length of gas. Now, I hope that, for those of you that are just starting your Leetcode journey, we could do like for gas amount, right? In gas, we could do this iteration, but I hope you notice that when we are using the index for our for loops, we have a lot more control. And so while you can use this for iterating, in most of these problems, you're going to be using an index and then iterating through the length of an array. So just a kind of a side note there. Let's go ahead and start writing stuff. So our total, or our tank, remember what we did at the beginning of each run through the algorithm? We incremented by the gas at index I, and then what did we do? Total minus equal cost at I. We could do this in one line, but we're not going to. So what did we do? If the total was negative, so if our total was below 0, well then we couldn't start at this point. So we would have to change our start equal to the next gas station, which would be I plus 1. That's why we're using for I in range here, because we need to be able to identify the next gas station easily. And we have to zero out our total, right? Because we're assuming at the start of the trip, based on the description, that we have an empty tank. So we'll zero that out. And then once we get to the end of this algorithm, it'll return the starting point. Now let's go ahead and run this. Should work. All right, so we've got our example down here. This is from the one we did. Starting point at 3. Let's go ahead and submit. None. Start at 0. I don't know why I changed it to none, but let's try it again. See, the reason that didn't work is if we started at 0 and that was the answer, well, we never would have updated start. And so it returned none. I don't know why I updated that. It's been a kind of a day for weird stuff like that. So we submitted it. Runtime's very good. Let's see, it should be big O of n. There we go. And our space complexity, we're not using any data structures, so this should be constant space. There we go. Anyway, sorry for all the arithmetic errors in the description. There's not enough coffee today. In case you're wondering why this channel is called Coding for Dads, it's because I am a dad and I have many, many children. And so sometimes the tiredness catches up with me and I say things that are wrong. And for that, I apologize. But I hope that this has been useful to you. If you like the videos, please leave a comment. I'd love to hear from you, see what improvements I can make. The channel's only been around for a little while, and I'm always looking to make things better. So thank you so much for watching. I hope you have a great rest of your day.